All right, so we're going to be factoring again today, but what we're going to look at is factoring what we call special products. Okay, so these are special products, and really, you should be aware of this anytime we have two terms. So if you look at all our examples, A has two terms, B has two terms, C two, D also has two terms. Even when we come down to here, again, we have two terms in all of these. So if you see two terms, then you should think, hey, this could be a special product, and you would apply these rules. Okay, so only learning how to factor special products. Okay, so the first special product we have is called the difference of squares. Okay, so this is fairly simple when you understand it, but until you understand it, it's difficult to get a hold of. Okay, but basically, difference of squares says if I have two terms and I'm subtracting both of them, and those two terms are perfect squares, okay, then we can factor it to be this. All right, so here I know that I'm looking for perfect squares. So numbers that I'm looking at are like, 1, 4, 9, 16, 25, 36, and so forth, right? So those are all numbers that are perfect squares. So those will be a key to know, hey, this could be the difference of squares, right? So I look at this and I see subtraction of two terms, and I know 49 is a perfect square, and x squared is also a perfect square because x times x is x squared, right? So I know that this is going to factor to be two different factors, one with a minus and one with a plus in it. So what I'm looking at is this part right here. Okay, so all I have to figure out is what is the value of A and what is my value of B. So here's what the formula looks like. A perfect square minus another perfect square is equal to the quantity of A minus B times the quantity of A plus B. So I just need to figure out what A and B are. So I get A from this term, right? So A is basically the square root of x squared, which gives me just x. So the A value is just x. And then I take the 49, and that'll be my B value. So the square root of 49 will give me a B value of 7. So these two are the terms I'm going to use to plug into my formula. So where there's an A, instead of A, I'm going to put X. So there should be an X here and an X there. And then the B has a value of 7. So there's going to be a 7 there and a 7 there, and I'm done. Okay, so there is my difference of squares. I'm finished. Okay, so essentially when I recognize this is the difference of square, I'm taking the square root, and then filling in. Okay, for instance, B. I know that, again, this is the difference of squares. So I'm going to have two factors with opposite signs. And then this first term is going to be x and x because I know that x times x gives me x squared. And then the last term times the last term is going to give me 25. So I should know that that is 5. Okay, if you don't, you just take the square root of 25 and it'll give you 5. And so I'm done. So it should be that simple, right? I should be able to look at it. And again, here's the difference. I do know that 4 and 81 are perfect squares. So again, I make my two sets of parentheses, and then I can take the square root of all this, or I can simply just ask myself, the first term times this first term is going to give me 4x squared. So that has to be 2x. Okay, and they're going to be the exact same value. So 2x times 2x gives me 4x squared. Check. Then I know this last number times the last number is going to get me to 81. And again, it should be the exact same number. So that's going to be 9 and 9. So negative 9 times positive 9 gives me negative 81. Okay. And so then for this last one, once you've figured out that pattern, minus plus, this is going to be 3x and 3x. And then this is going to be 6 and 6. And I'm done. Okay, so the difference of squares, once you figure it out, is fairly simple. You just have to be able to recognize it. So when you see two terms and you see a minus sign, ask yourself, is this the difference of two perfect squares? All right. Sum or difference of cubes now. Okay, so the difference of squares only works with subtraction. Okay, square, square. Now we're going to have a cube, and this works with both addition and subtraction. Okay, so now again we have a formula. So now we have two different formulas. You don't have to memorize these. These would be provided for you, right? And I have to ask myself if these are the sum or difference of cubes. So now what I'm looking for are perfect cubes. A cube means that it's multiplied times itself one time. So if I multiply one times itself, 3 times, one times itself 3 times is a 1. 2 times itself 3 times gives me 8. 3 times itself 3 times gives me 27. 4 times itself 3 times gives me 64. And 5 times itself 3 times gives me 125, and so forth. So now I'm looking for these special values, these cubes. These are perfect cubes. Okay, so all these examples are the sum or difference of cubes. So I look at this, I have two terms. I should think special products. It's the sum, so things that give me a hint that it's not difference of squares is 1, it's a plus sign, and 2, it's a cube right here. So I have the sum of cubes, and then I'm going to use this formula right here. So this is the sum of cubes. So I'm using this part. Okay, so that's what it's going to look like when I factor it, right? So I know that this is going to give me 2 factors. One's a little bit longer than the other. And I know those are going to be the signs that are there. So there's the plus, there's a minus, and there's a plus. So those signs will never change. So now what I have to do is figure out the value of A and B. So again, A is equal to this time the cube root of x cubed. So A is simply x, right? So I took the cube root of this. And then B is the cube root of 8. So the cube root of 8 is 2. Okay, if you need to know how to do that on Desmos, we can open up a graphing calculator. It's this little keyboard down here. You show the keyboard, functions, miscellaneous, and then this nth root. So I could put the cube root of 8, and it'll tell me 2. Okay? So that's where B is 2. And now it's simply just plugging in. So I know that I'm going to use these 2 values. And so this one says A. See that? So this is going to be A. So that's just X. The next number is B. So that's just a 2. But then this is where things get a little tricky. Then it says this number in the next parentheses is A squared. So this is A squared. So that means I have to take X times itself. So X times X gives me X squared, right? And then this middle term right here is A times B. So it says AB. You see that? AB. So X times 2 gives me 2X. And then the last term is B squared. So I have to take 2 squared, which is 4. And so this is my final answer. So that was B squared right there. Okay, and that's how you find the sum of cubes. Okay, so here's another sum of cubes. So I know already, hey, there's 2 terms. I recognize those as perfect cubes. So I know that I'm going to have 2 sets of parentheses. The first one's going to have a plus. The next one's going to have a minus plus, okay, based off of the formula, okay, given. Based off of the formula given. I'm just using this formula again. And then I have to figure out what A is. A here is simply X, right? And then B here is I have to find the cube root of 27. So that's where I can come back over here. I can change that 8 to a 27, and it gives me a 3. So the cube root of 27 is 3. So then B is 3. And now it's simply just plugging in, right? This was A, this was B, A squared, A times B, B squared. So A is the same thing as X. B has a value of 3. A squared has a value of X squared. A times B has a value of 3X. And then B squared has a value of 9. So all these values are essentially from here, okay, from these two values right here. I'm just substituting. That's all I'm doing. So I find what A and B are, and then I substitute, okay? And then now, again, I see two terms. I think special. I see a minus sign. I go, oh, hey, 64 is a cube and a square, perfect square. But this cube tells me I'm going to have the difference of two perfect cubes because it's cubed, not squared, right? So again, I'm going to have two sets of parentheses. This time, based on this formula, I'm using the difference of cubes, okay? So now I have a minus plus plus. So the only thing that changes are my signs now. Minus plus plus. This is still going to be A. That's still going to be B. A squared, AB, and B squared. Okay, so the only thing that changed with the subtraction is the signs. Those two signs just switched. So A has a value of X. And B has a value of, and then we check it. So I need the cube root of 64, which is 4. So B is a 4. And then I just substitute in. This is X, that's 4. This is X squared, this is 4X, and this is 16. And I'm done. It's that simple if you understand how to read the formula. Okay, here are a few more problems. Again, difference of squares, or sorry, difference of cubes here because of the cube. So this is going to be 5x. B is going to be 2. And if you need to check that, 125, right? 125, cube root is 5, okay? So 5x and 2, so I know again, two sets of parentheses, a minus plus plus because this is the difference of cubes. And then I just substitute. This is A, B, A squared, AB, B squared. So A is 5x, B is 2. A squared is 25x squared, okay? And then A times B now is 10x, and B squared is 4. Okay, so I got that by just squaring this. 5x times 5x gives me 25x squared. And then F, this is the sum, sum of cubes. My gosh, I can't spell today. So plus minus plus. And then I need to figure out what A and B are. A is 2x, B is 3. Again, those are perfect cubes. And I just fill in 2x, 3, 4x squared, 6x, and 9. Again, because our formula says this is A, B, A squared, A times B, B squared. Okay, and then I do want to talk about E. E's a little bit different, right? This does have a GCF. So 16 is a perfect square. Okay, it's not a perfect cube. And 250 is neither. Okay, so if you think, okay, it's nothing, can I take out a GCF? So I can take out a GCF of 2 here. And then what I'm left with is 8x cubed plus 125. Okay, and so now if I just look at what I highlighted, that is the sum of cubes. So now I know that I can factor that part out more. So I'm going to factor just that part out. Again, I need to know my A value, my B, and then I know that all this just kind of falls into place. So A is from this number, so that gives me 2x. B is from that number, that gives me 5. So I have 2x here, a 5 there, a 4x squared, a 10x, and a 25 there. That is my final answer. All right, so that one a little different because it did have a GCF at first. Okay, so we have practiced factoring quite a bit. A little new things here that we had to add, but here's an important table. So what I have found in my experience is that this part is what blocks us from answering those questions, is figuring out what method we're going to use. So basically figuring out, hey, is this normal factoring? Is this factoring by grouping? Is this a special product, right? And so what we need to look at is, if I look at all these and I say which one's just normal factoring, so like the slide and divide method. So what I'm looking for are 3 terms. So this one has 3 terms. I'm just going to write the terms out here to the left. Terms. So this one has 3, this one has 3, and this one has 3. So all of those that have 3 terms, I'm just going to say slide and divide. So this is just normal factoring. Okay, slide and divide. So if it has 3 terms, normal factoring, what we've been doing all year long. Okay. Then the next easiest one to spot is anything with 4 terms. Oh, this one has 3 terms as well. So that one's also going to be slide and divide. Sorry, I missed that one. And then this one will have a GCF though. And then if we have 4 terms, so this one's 4. Okay, then any with 4 terms in it, we're going to use grouping. Okay, grouping. That's what we learned in the last class period. And then any with 2 terms. 2 is the one that's always tricky because we have to figure out, is it a perfect square or perfect cube? So these are with 2 terms. So this one's 2 and that one's 2. So let's look at this one. This one is the difference of 2 perfect squares. What I look at is what's the exponent on the x. Since it's a 2, I think difference of squares. So I just make sure that 9's a perfect square and 16's a perfect square. So this one, special product, difference of squares. And then I look here. Again, I have 2 terms. The difference, 64 is a perfect square and a perfect cube, but this x has an exponent of 3, so that tells me it's going to be a cube, so difference of cubes. So I say difference of cubes. Okay, and then you can go ahead and work on this. We can check it if you'd like, but you can go ahead and fill that out on your own.